loves fractions? Okay, I saw that look. Of course, I'm used to it. That's what I get every time I ask that question. Let me just ask you another question. Since fractions are so very popular, why do we need to even study them? And you're saying, that's a good question. Well, let's think about that. Got a piece of paper here. You know what the dimensions of that paper are? 8.5 by 11. Well, surely they could have made it 9 by 12, but they didn't. It's 8.5 by 11. And you know what the measurements of a 2 by 4 really are? Something like 1 3/4 by 3.5. So those of you who are in the construction industry who think you never have to deal with stuff like this, fractions are a part of our life. So I guess since we have to deal with them, maybe it would be a good idea for us to get acquainted with them so that they could be our friends rather than their enemies. So what is a fraction? I think that's part of the problem. When we talk about fractions, we really aren't clear on what we're talking about. So what I want to do is I want to go through a visual examination of a fraction and see if I can get it so you can look at it in a way that will help you see a little better and maybe make dealing with fractions a little easier so that you can make them your friends. Let's take the fraction, for example, 3/7. When you look at that fraction, what do you see? Every time I ask the students that, they kind of hem-haw around trying to figure out that they really don't understand what it is. So let's take a picture, let's look at a picture of it and see if maybe based on that picture we can get a clearer idea of what we're talking about when we talk about fractions. Now, you're going to have to excuse me and use your imagination a little bit. I'm not really good at drawing, and so you have to use your imagination a little bit. But I'm going to try and draw a picture that will sort of look like what we're talking about here. Okay, now what we got here is a rectangle with 7 equal pieces, and this is where you got to use your imagination. They're obviously not equal, but we're assuming that they're equal. And if we're talking about 3/7, we're talking about those. In other words, I have in my hole, and I'm not talking about digging with a shovel, I'm talking about a W-H-O-L-E. In my hole, I have 7 equal parts. And in this case, I'm dealing with 3 out of those 7. And when you say 3/7, that's kind of what you're saying, but it's kind of hard to get the image in your mind unless you think about it that way. So, the bottom number in any fraction always tells us the what that we're dealing with. The what. The top number tells us how many. Now mathematicians have given these a name. They call the bottom number the denominator. I don't know where they came up with that name, but that's what it's called, and everybody knows it by that name, so if you're going to talk about it, you might as well know the name. So that's the denominator, but it tells you what you're dealing with. There's one other thing you've got to make sure you're clear on when you look at that denominator, and that is this number tells you how many there are in a whole, W-H-O-L-E, how many equal parts there are in a whole. The numerator, that might be a little bit easier to remember because numerator, number, you know, maybe that tells you that, okay, it tells me what the number are that I have. So maybe that one's a little easier to remember, but the numerator is the top number and it tells you how many you have. Okay, so when you look at a fraction, if I'm looking at this, what I'm looking at, I see sevenths and I have 3 of them. And when I say sevenths, my brain pictures that there are 7 equal parts in a whole. Okay? So try when you're dealing with fractions to look at it like that. So if I write a fraction down here, 5/13ths, when you look at that, think I'm dealing with 13ths and there are 5 of them. So you've got a better picture of what you're working with. Now, one thing that's important to remember, fractions are numbers. They're just not whole numbers, they're parts of numbers. So everything that's true with any other number is true with a fraction. Okay, so what's going to happen if we multiply a fraction by 0? Okay, now sometimes people have a little trouble with this 0 part, so remember, if you're having trouble with it, instead of thinking of zeros, think of what 0 represents. Nothing. Okay? 0, nothing. So if I multiply 7 times nothing, what am I going to get? Okay, so if I multiply a fraction by 0, whatever that fraction is, that much times nothing is still going to be nothing, just like it is with other numbers. Okay, if I multiply a fraction by 1, so I've got 5/13ths here, and I've got one of those 5/13ths. If I multiply 1 times 5/13ths, what am I going to get? Okay, if I multiply 1 times 2, I get 2. 1 times 7, I get 7. 1 times any number is that number. And that's true with fractions as well. So 1 times any fraction is going to be that very fraction. So try to get those points clear in your mind, because then you already know more of what you think you do about fractions, because they're just numbers. Maybe if you're not so afraid of them, because you know they are just numbers, then you can work with them and learn what you need to work with them a little bit easier. So let's go from there. If you wanted to see a picture of a fraction, let's do like we do with numbers. I've got a number line here. There's my beginning point. There's where I measure from. And I want to know where that's the number 1. I want to know where, well, let's take this one we've got here. We've got 3/7. Now, 3/7 isn't a whole, because it's only part of it. 7 would be a whole, and we only got 3. So it's got to be somewhere between the 0 and the 1, doesn't it? If you remember that this name here, this sevenths thing we talk about, tells us we've got 7 equal ones, then if I split this part here, okay, I'll take one of those out. Now those are all equal. 1, 2, 3, 4, 5, 6, 7. Then 3/7 would just be right there. So if you look at a number line with all those numbers, everything in between the whole numbers are fractions. That's where the fractions are. But we're so afraid of them, we don't even want to write them. We pretend they're not there. But they are, and so we might as well learn how to deal with them. Okay, another thing that we need to know when we're talking about fractions is the idea of mixed numbers. I really want a magic wand so I can just wave my wand and all that stuff will go away so it wouldn't take so long. Okay, mixed numbers. One of the things I said before, one of the things that's really important is you learn that words mean what they mean. And they mean it in math too. If I talk about mixed numbers, when you think about the idea of what mixed is, then doesn't that sound like we're mixing something together? That's what we're talking about when we talk about mixed numbers. For example, if I have 4 and 5 ninths, what I'm mixing together is the whole number, 4, and the fraction part, 5 ninths. And if you think about it, when I say that word and, it means I've got 4 plus I've got 5 ninths more. So I could actually write this 4 plus 5 ninths. But that would be a little extra work, and we're always trying to find shortcuts, so we don't do that. We just write 4 and 5 ninths. But this is what it means. And if I wanted to find it on the number line, I would go over to the number 4, and then I would go 5 out of 9 equal parts between the 4 and the 5. 4 and 5 ninths. Now, if I want to write, I want you to think about this, because what I told you about looking for fractions is important even here. Thinking about fractions that way, and any time at all you're dealing with anything involving fractions, you should always look at the denominator first, because that will tell you what you're working with. So when I look at this, and we'll take this one off because we want to see it the way we're going to be seeing it. When I look at 4 and 5 ninths, I say, I'm dealing with ninths. Now I have a little bit more than I had before. If I want to write that as an improper fraction, I just have to use this idea a little bit, and it's easy to do. This 4 out here means I have 4 of those WHOLES. Because I'm dealing with ninths and I'm clear in my mind what that is, I have 4 groups of 9. Now you think about that for a second, and I'll bet you your brain tells you to get the total, you multiply the 9 times the 4. Because I got 4 groups of 9. Or you could do 4 times 9, that probably makes a little more sense. 4 times the 9, which gives me 36 ninths, plus I've got these 5 here. It says 4 plus 5 ninths. So I've got 36 here, and 5 more gives me 41 ninths. Now, that is called an improper fraction in math circles. Excuse me. I think it's because people think that it's terribly improper that that poor little 9 has to carry that great big 41. Well, let me just ease your mind a bit. This guy's a tough guy. He can handle that 41 without any problem at all. So that's not going to be the determining factor of whether we'll write it like this or we'll write it like this. 4 and 5 ninths or 41 ninths. The thing that's going to be the determining factor is which makes more sense in the situation we're talking about. As an example, has anyone ever heard somebody talk about 15 halves of a cup of flour? Okay, you wouldn't talk about it. But we would talk about 7.5 cups. So, remember, this is perfectly all right until you're dealing with a situation where it makes more sense to say it the other way. But now think about this. Changing from here to here was really fairly simple, and we don't even have to remember the rule if we remember the idea. I'm dealing with ninths. I have 4 full groups. plus these 5 here. So altogether that's 36 plus 5 ninths, or 41 ninths. If we go the other way, let's take here, say we've got 23 fifths. And we want to write it, because it makes more sense, we want to write it as a mixed number. Okay, so same thing. I look at this and I see I'm dealing with fifths. And because of that, I know that for every whole, W-H-O-L-E, I have 5 of them. This is called improper because this number is bigger. So basically we have too many of these things. So what we're going to do is we're going to change some of those extra ones we have into wholes, W-H-O-L-E-S. Okay, so we look at this and say, we're dealing with fifths. How many fifths does it take to make a whole? 5. How many groups of 5 are there in 23? Well, we find that. That's another one of those reasons for thinking about the division the way I've taught it. We want to know how many groups of 5 there are in 23, so we divide 23 by 5. And hopefully as we get familiar with our numbers and do this, we know that there are 4 full groups of 5 in 23. So we've got 4. Now those 4 5 groups, or those 4 5 totals, give us a total of 20. So that takes up 20 of them, but that means we still have 3. So I have 4 full groups, and I have, in addition to that, 3 fifths. So if I understand fractions the way I've tried to get you to look at them, and the way I want you to keep working at it and learn till that happens, till you've programmed your brain so that's what it sees, then changing from mixed numbers to improper fractions, or from improper fractions to mixed numbers, is really fairly simple. Just because we know the idea of fractions the way I recommend it to you. So take the time and learn it. It will make working with fractions a whole lot easier. Good luck. Hope you can do it so that you'll be friends with fractions instead of enemies. See you later.